1. East African Highlanders, masters of thin air. High in the cloud-scraping plateaus of Ethiopia and Kenya, human physiology performs a quiet miracle. Populations like the Oromo and Kalenjin thrive effortlessly at altitudes where most visitors struggle for breath. Their secret isn't simply more red blood cells, it's a profound systemic efficiency. Their bodies appear to extract and utilize oxygen with an almost preternatural grace, likely through enhanced capillary networks and supremely efficient mitochondria within their muscles. This isn't an abstract trait, it's the foundation of legendary endurance running, where athletes seem to glide across marathon courses. Their legacy is a masterclass in economy, building unparalleled stamina not by brute force, but by perfecting the use of a limited resource. Yet this exquisite adaptation has its trade-offs, such as increased risks during pregnancy at altitude, reminding us that every evolutionary strength exists within a delicate balance. 2. Indigenous American Ancestry, the physiology of perseverance. The ancestors of today's Indigenous American peoples undertook one of humanity's most epic journeys, traversing continents and adapting to ecosystems from tundra to rainforest. This history of immense movement and resilience is etched into their physiology. In groups like the Tarahumara of Mexico, we see extraordinary aerobic capacity and running economy, traits born from a nomadic lifestyle covering vast distances. In the high Andes, Quechua and Aymara peoples showcase another facet of this adaptive genius. Large lung volumes and efficient hemoglobin that conquer the challenges of thin mountain air. Their bodies became instruments of endurance, finely tuned for long journeys and high altitudes. The modern challenge for these lineages often lies in a metabolic system honed for scarcity, now navigating a world of caloric abundance, a poignant clash between deep history and the present day. 3. Pacific Islander heritage, the voyager's constitution. The settlement of the Pacific Islands stands as a testament to human courage and ingenuity. Navigating vast oceanic expanses in outrigger canoes required not just seafaring skill but a specific physical fortitude. Pacific Islander ancestry often includes genetic variants associated with efficient energy storage and muscular strength, a thrifty metabolism crucial for surviving long voyages and periods of unpredictable food supply. This legacy manifests in powerful, robust builds capable of tremendous feats of strength and endurance. It was a biology perfectly suited to building communities on new islands, farming tough soil, fishing, and navigating. In contemporary settings where calorie-dense food is constantly available, this once vital efficiency can become a metabolic liability, highlighting how a survival trait can struggle when its original environmental context vanishes. 4. Arctic and Inuit lineages, turning cold into fuel. In the stark, beautiful brutality of the Arctic Circle, Inuit and related peoples developed what may be humanity's most specialized metabolism. Facing extreme cold and a diet almost exclusively of marine mammals and fish, their bodies learned to use fat not just as insulation, but as a primary fuel source. Genetic adaptations in the FADS gene cluster allow for highly efficient conversion of omega-3 fatty acids into energy and heat. Coupled with increased brown adipose tissue, the body's good fat that generates warmth, and compact body proportions that minimize heat loss, these traits form a comprehensive biological winter survival system. 5. Subsaharan African Ancestry, strength and immunity forged under the sun. The diverse genetic tapestry of sub-Saharan Africa tells a story of triumph over some of humanity's oldest adversaries, intense tropical heat and relentless disease. Here, evolution sculpted a formidable dual legacy. One is a propensity for explosive athletic power and endurance, linked to muscle fiber composition and efficient thermoregulation, traits visible on the world's athletic stages. The other is a complex immunological heritage. Variants like the sickle cell trait and G6PD deficiency, while potentially harmful in their homozygous form, arose as powerful shields against malaria, reshaping survival odds for generations. Furthermore, eumelanin-rich skin provided a sophisticated natural sunscreen, protecting folate stores from UV degradation. This ancestry embodies resilience, a deep-rooted capacity to not only survive extreme environments, but to draw strength from them. 6. South Asian ancestry, metabolic agility in the tropics. Across the Indian subcontinent, generations adapted to a mosaic of climates, from humid deltas to arid plains. The resulting physiology is one of clever compromise and efficiency, A typically leaner, linear build promotes heat dissipation, a natural cooling system for tropical life. Genetically, many carry a high number of AMY1 gene copies, enhancing the ability to digest starchy staples like rice and wheat, a direct adaptation to ancient agricultural societies. This metabolic agility, however, faces a modern paradox. A system exquisitely tuned for energy conservation and efficient carbohydrate processing in a context of variable food supply can be vulnerable to the constant caloric surplus and sedentary habits of contemporary life, explaining elevated risks for metabolic syndromes even at lower body weights. It is a biology of brilliant efficiency, meeting an environment of unending abundance. 7. Southeast Asian heritage, the tropical equilibrium. In the lush, demanding ecosystems of Southeast Asia, the human body evolved toward a compact, heat-shedding design. Shorter stature and slender limbs maximize surface area relative to mass, facilitating cooling, a vital adaptation in relentless humidity. Darker skin tones provide robust protection against intense UV radiation without overheating. This package of traits represents a finely tuned equilibrium with a specific environment. High sweat gland density, efficient starch metabolism from a diet centered on rice and tubers, and electrolyte conservation mechanisms all speak to a life in harmony with the tropical forest. When removed from that context, however, this same biology can struggle with cold sensitivity, vitamin D synthesis in less sunny climates, and rapid weight gain on high-fat Western diets. 8. Middle Eastern and North African ancestry, the desert's economy. Life in the desert demanded mastery over two precious resources, water and energy. The ancestral populations of Arabia and North Africa evolved a physiology of profound conservation. Their kidneys became exceptionally efficient at reclaiming water, while sweat mechanisms optimized cooling with minimal fluid loss. The widespread presence of lactase persistence, the ability to digest milk into adulthood, provided hydration, calories, and nutrients from livestock, a lifeline in arid landscapes. These traits, combined with lean builds and skin pigmentation balanced for sun protection, created a human form exquisitely suited to arid extremes. The modern challenge for this lineage is that these once life-saving conservative mechanisms can contribute to hypertension and kidney strain when paired with sodium-rich processed diets and more sedentary lifestyles. 9. Central Asian ancestry, the steppes stamina. The vast open steppes of Central Asia, home to history's great nomadic empires, forged a physiology of raw stamina and adaptability. A life spent on horseback, enduring temperature extremes and high altitudes, selected for strong cardiovascular systems, robust lungs, and a metabolism adept at processing high-protein diets rich in dairy and meat. This is a legacy of motion and resilience. Genetic markers suggest adaptations for efficient oxygen use and a rugged immune system shaped by constant exposure to livestock and new pathogens. It was a body built not for comfort, but for endurance across an unforgiving horizon. In today's world, this ancient stamina now contends with modern sedentary habits, creating a discord that tests this inherited fortitude. 10. Northern European ancestry, harvesting the faintest light. In the latitudes of Scandinavia and the British Isles, where winter brings profound darkness, evolution pursued a strategy of light capture. Pale skin, low in melanin, acts as a biological solar panel, maximizing the production of vitamin D from scarce sunlight, a non-negotiable requirement for bone health and immunity. This was paired with another key adaptation, lactase persistence, allowing adults to digest dairy, a crucial source of calories, calcium, and vitamin D during long winters. Furthermore, genetic predispositions for efficient fat metabolism and non-shivering thermogenesis helped conserve energy and generate heat. It was a holistic adaptation to cold and scarcity. The modern irony is that this light-optimized skin is now vulnerable to damage under stronger suns, and indoor lifestyles can still lead to vitamin D deficiency, demonstrating that even our most elegant adaptations are not future-proof. 11. East Asian ancestry, an integrated toolkit. East Asian ancestry presents a cohesive suite of traits fine-tuned for the region's distinct climates. A genetic variant, EDAR370A, influences several features: thicker hair shafts, increased sweat gland density, and distinctive tooth morphology. This integrated package likely aided in thermoregulation and protection in humid, variable environments. Metabolically, adaptations reflect historical diets centered on rice and vegetables, promoting efficient energy use and storage. Another famous variant, ALDH2, causes the alcohol flush reaction, a physiological deterrent against alcohol consumption that carries its own complex health implications. This ancestry illustrates how evolution can weave a common thread through seemingly unrelated traits, hair, teeth, sweat, and metabolism, to create a cohesive adaptive response.